Hello everyone, this is Miguel Greenberg, and today I want to talk about asynchronous programming once again. The specific topic is a comparison between the async models used by Python and JavaScript. Um, a few days ago, I posted this Twitter poll to see what my followers thought about this, which of the two models they preferred. And you can see that for my audience, which is heavily Python based, as you would imagine, there is a slight edge towards people who prefer the JavaScript async model based on promises versus the Python model, which is based on coroutines. Now, I realize that when you look at code, async code that uses async and await in Python and in JavaScript, you may look at it and you may not realize that there's a difference, right? They actually look very much alike. So my goal with this video is, well, there are several goals. First, I want to show you what the difference is, how the async model in Python works, and how the JavaScript async model works. So I'm going to show you the two of them. I'm going to tell you why I'm also in the group that prefer the JavaScript promise-based async model. So I'm going to tell you why I don't like the Python model as much as the JavaScript model. And then finally, I'm going to show you a new experiment that I've made to make the Python async model work like the JavaScript model. So all of that we're going to do today. So let's get started. So here I have two terminals. So on the left side I'm going to do Python. On the right side I'm going to do JavaScript. So we're going to try a couple of simple things, and that I hope will clearly show you what the difference between the two models is. So in Python, we are going to run a shell. I'm going to do this in a shell. You may not know this. A lot of people don't know this. You can run a shell with this command, python-m async.io, and that gives you a supercharged shell that runs under async.io. And because of that, you can run await directly in the prompt. A limitation that actually both Python and JavaScript have is that when you use the await keyword to wait for an asynchronous function, you can only do so inside an asynchronous function, a function that you declare as async. So by running an async REPL prompt, I avoid the complications of having to create functions or async functions, only so that I can test await examples. So I'll be able to do await directly in the prompt. So let's go ahead and make a simple async function. So this is async def. The function is going to be f. We are going to print something just to see that the function is running. So f is running, and then we are going to return a value. So we're going to make this very simple. I could, well, actually, well, I don't know. I could add something like await, sleep, or anything, but it doesn't really matter. It doesn't make any difference. So let's keep it simple. So there you go. So this is the function. So let's say you want to run the function now. So you will be tempted to do something like this, right? Result equals f, and then we call the function. But you, if you expected the function to run and print, it didn't, right? The function's not running. So what happened here? What's this result if it's not the 42 that we have in the function? So it's some weird thing, a coroutine object. We don't really know what that is. We know it's part of the Python async model, which is based in coroutines. But it's really strange that you called the function and the function did not run. So So this is what I probably the only or the main thing I don't like about the way Python does async. Um, so how do you get the function to run? There's a couple of ways, but the main way to make the function run is to await it. So you can say await, and you await the coroutine object that we have as a result of calling f. So when you await the function only then it starts. So it runs and then it gives you the 42 return value from the await. The await gives you that result. So I find this very, very annoying. Many times I forget to add the await, right? Basically, when you call a function, you need to know if it's synchronous or asynchronous. And if asynchronous, you have to remember to prepend the await. Because if not, the function doesn't run. You don't get an error even, right? So it's not an error to call the function without await, right? Because there are legitimate purposes to doing so, which are advanced. I'm not going to talk about that here in this video, but sometimes you do need to do it. But when you do it by mistake because you forget, you're used to call the functions like normal functions, you don't get an error, right? So your application runs in a weird way. You start getting weird side effects. Maybe when the application exits, you will get a warning that something like a feature was not awaited. If you have this type of mistake, you've seen that. It's really weird. So I definitely don't like this. So this is Python, right? So let's move on to the right side and see how this works in JavaScript. So Node also has a little trick to run a REPL prompt that can run await directly. So this is with this experimental REPL await. So I'm going to run it that way so that I also get a chance to await directly in the prompt. So let's write f in JavaScript now. So for this, I'm going to use the new, new, it's not really new anymore, but anyway, the newer arrow syntax. So I'm going to declare a variable, and then I'm going to use an async arrow function to define the body of the function. So this is going to be, so here we're going to do console log f is running, and then we return the 42, and there we go. So this is exactly the same function, right? So if we do this, here we get a different behavior, and this is actually the core difference between the two models. So when you call f runs in JavaScript, which in my opinion is the expected, right? If you call a function, the function should run. Now, what's result, right? Is 42? What do you think? Result is not 42. Result is a promise. In JavaScript, async functions are normal functions that have the constraint that they must return a promise, right? So this is the difference. A function that returns a promise is a normal function. If you call it, the function runs, but at the end, it needs to return a promise. So the async keyword that you add here, it's really syntactic sugar that the compiler uses to basically move the code that you write in the function a little bit, so that instead of returning 42, it returns the promise, but the function runs anyway. So what's the difference? If the function runs, why not return the 42, right? The difference is that a normal function is a blocking function that's what it needs to do and returns. An async function is supposedly going to do things that may run for a long time in the background while you do other things. So the whole point is that when you run an asynchronous function, the function should start all these background operations and then return the promise. And the promise is basically the way the caller can reference that background work that is happening in parallel with itself continuing to run. I hope I'm making sense here. So if this f was, let's say, it sends a request to some API and waits for the response. If you say let result equal f, then the request is going to go out, right? And you could continue doing things after you call f, and that those two things will happen in parallel, right? And the promise is the way that you have to then check on that asynchronous work that's happening in the background. So if you want to know the result of the function, you do the same thing that you do in Python. Actually, in this, both languages they do the same. So in Python, you await the coroutine. In JavaScript, you await the promise. So you can await the result, which is our promise. So you await the promise, and then you get the result. So if going back to the example of a long web request, if you await the function before the function finished all those background operations, then await will wait. That's exactly what it should do, right? Wait. In the case of Python, await is not only waiting; it's also running the function, which is confusing and unexpected in my opinion. So this is the difference. There are other things. Some are pretty cool that you can do with promises that you unfortunately cannot do with coroutines. And by the way, if you are if you know if you have advanced knowledge of the Python async model, a promise in JavaScript has some similarities to what in Python async IO is called a future. So definitely not a coroutine, but it is somewhat similar to a future, which is in the same way as a promise. It's basically something that you can hold on to that will keep track of a background operation and will let you know when when that operation completes. So this is the difference. And the other day I was thinking about this difference, and I started thinking if it was possible to make Python work following the promise-based model. Can we make Python use promises in the way JavaScript uses promises for async functions? And I spent maybe half a day, and as usual, when I come up with a crazy idea, I end up with a new package at the end. So this was like that, and I created a package. It's called Promisio, which is sort of a short of Promise IO, and I'm going to show you how that works. Let's start a new shell here. So so Promisio has, among other things, it has a promise class. So I implemented JavaScript promises in Python, and another thing that has is a Promisify decorator. So with Promisify, you can take a Python function, it can be a normal function or an async function, doesn't matter, and it converts the function to a promise-based function that works in the way JavaScript async functions work. So let's repeat the same F exercise, but now let's use Promisify to make it a promise-based function. So this is going to be a function that is decorated. So async def f. We're going to do the print and the 42. So there we go. So this is a promise-based function now. So if I now call f and assign it to result, f did run right? So we have the print. So f completed, and result is a promise thing, something that you most of the time you don't need to worry about. In the same way, you don't need to worry about the promises in JavaScript unless you want to, and then you can. But normally you don't. You use await. So here we have a promise, and now we can await the sorry, not promise. Oops, what happened here? I lost my terminal. Oh, there we go. So we can await the result, and we get the 42. Now, just for fun, I'm going to show you that this also works with regular functions. This is not an async function, but we're going with the definition that that an async function, a promise-based async function, is a function that returns a promise. It doesn't need to be async. It just needs to return a promise for any kind of async work that or background work that it does. So we can apply this to a normal function as well. So here we have this, and this one I put an argument, and here we're going to return the input argument doubled. So there we have G, and we can say await G21, and it prints, and then we get the 42. And if we don't want to wait for the function, we want to let it run in the background, we can just say, like we did before, we can do it like this, and then the function is going to start. We are going to get back control before the function finishes. We can continue running on the next line, and in parallel the function will run, and then when we're ready to get the result, we can await it. For those of you who are familiar with promises from before async await existed in JavaScript, here when you have a promise, another way that you can use to get the result is to say, so result is our promise, so you can create chains of promises. So when the promise ends, you can do another thing that returns another promise, and then another thing, and you do that not next, then, by using the then function. So here you can say result, and then call this function console log, which will print the result to the screen. So you could do that. You could do it like that, and here is the result. Now we go back to the Python side on the left, and here result is a promise, and we can say result then, and we call print, and we also get the 42. We get the this, and this is actually that the then function returns another promise that you can then add another then, or a catch, or there's a number of things that you can do that you're welcome to investigate. You can read the JavaScript documentation for the promise class if you are into that. There are also pretty cool ways to run multiple things in parallel. There's one where you can run a bunch of things in parallel, but then when the first of all those things returns, completes, then you get the result immediately. So basically you launch a bunch of things, and it's called race because it basically it sets up a race, and the first one that completes, you get that result, and a number of other things. So I implemented all of that for fun on the Python side. But the most important thing, and what I really like, is that now I can call a function as a function, and I don't have to keep track of an async function versus a regular function. So anyway, this was a fun experiment. I don't know if it's going to take off because it's built on anything that I did. It's actually it's done legally. I didn't use any magic tricks. I didn't implement anything obscure for this. As I said before, promises in JavaScript work pretty much like futures in Python. The promise class that I implemented is based on futures. It uses futures internally. So So it's very much compatible with anything you want to do. You can permissify your own functions. You can permissify functions from libraries that you use. It doesn't really matter. So anyway, I hope you found this interesting, and you at the very least you learned a different way of doing async if you were not familiar with the JavaScript model. And I hope you like it and decide to give Promisio a try. Thank you so much, and I will see you in the next video. Bye bye.